Hello everyone, my name is Lennart and my partner is Minyang, and we're going to present the capabilities of the Python package Scipy today. So what is Scipy? Scipy is a free and open source library used for scientific computing. More specifically, Scipy is a collection of mathematical algorithms that are built on NumPy data structures. Scipy is organized into subpackages that cover different scientific computing areas. It was initially released in 2001 by merging code from Travis Oliphant, Eric Jones, and Piero Peterson. Today, many people consider Scipy a data processing environment rivaling with MATLAB. As I've mentioned, Scipy has various subpackages that cover different scientific computing domains. Some of the more commonly used subpackages are the cluster package, which provides extensive clustering algorithms, the integrate subpackage, which we will use later to demonstrate integration with Scipy, the interpolate package, which allows interpolation as well as smoothing splines, and the optimize subpackage, which we will also use to present an optimization problem. However, there are also various other subpackages. In general, and important to mention is, all of the subpackages rely on mathematical concepts. The first example we're going to look at is an integration problem. As for other packages, to import Scipy, we simply write import Scipy as sp, or we import the specific subpackage. In this case, we only need the minimize and the integrate function, which is why we only import those two subpackages. Well, what is integration and what can it be used for? Integration is a mathematical concept that can be used for finding areas, volumes, central points, and has many other useful applications. In the first example here, we simply integrate a self-created function. We write integrate.quad, input the function, the start and end point of the integral, and Scipy simply derives the result for us. Now let's look at a more applicable example and try to calculate the value of pi. As you can see in this picture, the equation of a full circle with radius equals 1 follows the equation x squared plus y squared equals 1. From that equation we can derive the equation of a half circle. The equation of a half circle follows y equals square root of 1 minus x squared. Now we can use that function and integrate it from the start point minus 1 to endpoint 1 to calculate the area of the half circle. To do that with Scipy, we simply write again integrate.quad, input the function of the half circle, the start point of minus 1, the end point of 1, and we integrate that function. Since we are interested in the area of the full circle, we have to multiply the result with 2, and as you can see, the result shows the value of pi. Now, Minyang is going to introduce an optimization problem with Scipy.
One of the most practical usages of the Scipy package is that we can use it to solve optimization problems. Here's one example. In the game League of Legends, a player's effective health when defending against physical damage is given by E equals to health times 100 plus the armor divided by 100. And the health costs 2.5 gold per unit. The armor costs 18 gold per unit. Say we have 3600 gold and we want to optimize the effective health by purchasing the health and armor to survive as long as possible against the enemy's attack. How much of each should we buy? To solve this optimization problem by Scipy, we need to first identify some elements of the function. The optimization objective is that we want to maximize the effectiveness health, but Scipy only has minimize function. We can convert the maximize to minimize the negative effective health to just put the negative sign to the equation. And the constraint is that we cannot spend more than 3600 gold on health and armor. The bound is the range of the variables, where the bounds of health should be from 0 to 3600 divided by 2.5 because the player cannot spend more than 6600 gold on health, and similarly for the armor, the range should be from 0 to 3600 divided by 18. Then let's first define the function of our objective. We would like to return the negative effective health, and since the answer would be a list of values, here the x0 indicates the amounts of health the player buy, and the x1 indicates the armor that the player is going to buy. Then similarly, we also define the constraint. For the constraint, we need to have a function greater or equal to 0, so we need to move the left side of the constraint to the right side, which is 3600 minus the amount of money spent on health and armor. The constraint elements in the Scipy minimize function should be a dictionary where the type is inequality, and the function is the constraint function we just defined it. And the bounds, as we mentioned before, the bound for health should be from 0 to 36 divided by 2.5, and the bound for the second variable should be from 0 to 3600 divided by 18. Finally, we put all the elements together. We type minimize and the objective function, and then the x0 is the initial guess of this answer, and it doesn't affect the real solution, so we can just put 0 to it. And the bound is the bound we just defined it, and we use the SLSQP method to solve this optimization problem, and the constraint is also the constraint that we just defined. Then we run the code, and the solution indicates that the player should buy 1080 health and 50 armors to maximize his effectiveness health. Now let's come to the second problem. 10 minutes later in the game, we have 1080 health and 10 armor. Now we only have 720 gold to spend, and the price of health and gold doesn't change. Again, we want to maximize the effectiveness health. The objective is still the same, that we want to minimize the negative effectiveness health. But since we already have 1080 health and 10 armor, we need to add them to the H and A. Also, the constraint changes because we have less money to spend. So does the range. We need to add the initial health and the initial armor to the objective functions. And we also need to change the constraint from 3600 to 720. The bounds also changes because the money changes. The constraint, in the constraint dictionary, the function we use should be the new one. And for this, then we run this code. The solution indicates that the player should spend all his money on armor to maximize his effectiveness health. Now let's come to the third problem. 30 minutes into the game, we have 2000 health and 50 armor. Now we have 1800 gold to spend, and the price of health and armor still doesn't change. Again, we want to maximize the effectiveness health. This problem is almost the same as the previous one. We only need to change the initial health from 1800 to 2000, from 10 to 50, and to change the constraint from 720 to 1800. The solution indicates that the player still needs still should spend all the gold on the armor to maximize the effectiveness health. The League of Legends optimization problem is just one of the very simple examples of optimization in the real world. In financial area, the investor can use the Scipy optimization function for portfolio optimization given the different risk and the return of different stocks. It can be also applied in airline industry to optimize the flight schedule. That's all for our presentation. Thanks.